Today we're working on Module 9, Lesson 8, where we're going to be learning more about inequalities. And today we're going to be graphing those inequalities. But before we get into the graphing them, there's something I do need to teach you that we've not really covered yet. And that is what kind of dots you use with what kind of symbols. So what we're going to do is we're going to take and start off with a greater than or less than. Anytime you use a greater than or less than, you're going to use an open circle on the graph. So let's just say, which is not going to be the case, but let's just say we had a graph where we had, I don't know, 5 is greater than x. That would mean that we would have, actually let's do that the other way around. Let's take and do x is greater than 5, just to keep things simple. That means that where you would have your 5 on your number line, which of course you know your number line starts at 0, it goes up here to 10, so where you'd have your 5, because it is a greater than or less than symbol, you would put an open circle. And then you'd ask yourself, is x bigger than 5 or is x littler than 5? Well, the alligator's eating the x, so x is bigger than 5. That means that our number line is going to go to the right. However, if I'd had an or equal to, so a greater than or equal to, or a less than or equal to, this time we are going to use a closed circle to represent our dot. So right here, if that was 5 is greater than or equal to, on my graph, I would need to have that circle be solid. Now, if you think about it, when you were little kids and you were graphing points on the number line, they said, well, show me where 5 is. And you would put a solid circle on 5 because that solid circle represented where 5 was, what it was equal to. So if there's an or equal to, you have to fill in your circle. If there's not an or equal to, then you're going to have an open circle. So with that behind us, let's take and start looking at some of these problems. Caleb has at least $5. So I'm going to use a C for my variable. At least implies that he has more than $5 or he has equal to $5. So with that said, on my number line where I have a 5, am I going to use an open or a closed circle? It's going to be a closed circle because it's an or equal to. And then I have C is greater than or equal to 5. That means which side of that number line is greater than 5? That's going to be the number to the right. Now, some of y'all may want to take and try to do your number line like that, but it's going to be kind of hard, you can see, to see where you do the line. That's why I like to take my arrow and put it up above the line just like that. It makes it really clear what the answer is going to be. Let's look at the next problem. For this one, Tarek has more than $5. Well, once again, this time we got T, and we have more than, that means he has greater than $5, but is there any equal to in there? No, there isn't. So this time we're going to use an open circle on the 5, and once again, he has more than 5, so the arrow is going to go to the right. Next we have Vanessa. We're going to use a V, has at most $5. That means she could have less than $5. She could have equal to $5. Because it's an or equal to, we're going to use a solid circle. Let's go ahead and scroll up so you can see it. We're going to use a solid circle right there. And it could be less than that as well. So my arrow is going to go to the left-hand side. Any numbers less than 5 or equal to 5 are all going to be valid solutions. Now let's take a look at the next example problem. Here we have Kelly. She works for a quick oil change, and if customers wait longer than, that looks important. Longer than means greater than or equal to. So right there I have a wait that's greater than or equal to 20 minutes for an oil change. The company does not charge for the service. The fastest oil change she has ever done took 6 minutes. Show the possible customer wait times for which the company charges show the possible customer wait times in which the company charges the customer. Well, we know that if it is going to be greater than 20 minutes, it's going to be on the 20. It's an or equal to, so is it an or equal to? A longer wait time is not an or equal to, so I'm not sure why I put that there. It's going to be an open circle because it's a longer than 20 minutes, so the numbers that are going to be longer than 20 minutes are going to be these number right here. It says her fastest wait time is 6 minutes. Now that right there is what we call a distractor. That 6 minutes has absolutely nothing to do with our problem. It was put in there for Kelly to have a chance to brag about how quick she changes the oil, but in the end, it does nothing to solve our problem. All we care about is the numbers where the customers are going to, oh, hold on. My bad, I am wrong. So the inequality I had gave me these values. That's where the customer goes free, but that is not what we need. We need to know the numbers where the customer is going to have to pay. And those are going to be from where Kelly has her 6-minute record all the way up to and including the 20-minute window. So from 6 minutes all the way up to and including 20 minutes is going to be customer paying. And if it is a greater than 20 minutes, like I put on my graph right there, then it's going to end up going for free for the customer. Let's take a look at the next problem. Tell you what, y'all pause the video and work on this one, and then we'll come back and look at it together. Let's see how you did. Gurnez has been mowing lawns to save money for a concert. Gurnez will need to work at least 6 hours. That means he's going to have to work greater than or equal to 6 hours to save enough money. But he must work fewer than 16 hours in a week. Okay, so here that means he has to work less than 16 hours in the week. So we have two different inequalities going on here. One is where he's working less than 16 hours in a week. The other is where he must work greater than 6 hours. So what's this going to look like when we graph it? Here we got a or equal to for the greater than, so we're going to put a solid circle on that, and we know that we got an arrow going this way. But we also know that he has to work less than, but not including 16 hours. That's going to be an open circle. So anywhere in between greater than or equal to 6 and less than 16 is what your solution is going to be. That one was actually pretty tough, wasn't it? Let's take a look at the next problem. So for this one, actually you guys are going to pause the video now, and you're going to work these 5 problems on your own, and then we're going to come back and check our answers. Alright, let's see how you did. For the first one, Blayton is at most 2 meters above sea level. That means it could be less than 2 meters, or it could be equal to 2 meters. So I hit B is less than or equal to 2 using a solid circle on my graph. For number 2, Edith must read a minimum of 20 minutes. That means she can read exactly 20 minutes, or she can read greater than 20 minutes. So I have a greater than or equal to with a solid circle. Now the next one is pretty cool because it requires 2 different inequalities. Travis milks his cows in the morning. Have you ever milked a cow? I have. True story. Milked a goat too. Anyhow, he has never gotten fewer than 3 gallons of milk. So right here, never gotten less than 3 gallons. That means he's gotten exactly 3 gallons, and he's gotten more than 3 gallons. So the milk is greater than or equal to 3 gallons. However, he always gets fewer than 9 gallons. Never reaching 9 gallons, always less than 9 gallons. So I have a solid circle on the 3, I have an open circle on the 9, and then we have a line connecting them to show what the possible solutions are going to be for him to get for milk each day. Rita, this one's full of distractors. Rita can bake 8 cakes for her bakery each day. So far, she has orders for 32 cakes. Right now, here's the important part. Right now, Rita needs, so let's just start her highlighting it right here. Rita needs more than 4 days to make all 32 cakes. That's the only part of this whole sentence that matters at all. She needs days more than 4, so D is greater than 4. That gave me an open circle with an arrow going to the right-hand side. And then finally, for number 5 here, we got Rita must have all orders in place right now done in fewer than 7 days. So her days have to be fewer than, right now done in, 7 days or fewer. That means it could be exactly 7 days or less than 7 days. Exactly 7 days means I'm using a solid circle, and then all the days less than it means that you can go down from there. Of course, you would end up reaching a point where you'd have 1 day and 0 days, so you would actually have a window right there, but they didn't include those numbers in our graph. What are you doing next? Well, from here, I'm so sorry, we got more problems to work. Well, let's go ahead and pause our video and work on those problems. Well, I just realized these questions are taking us to a whole new level, so let's look at them a little bit closer. Kelsey's been mowing lawns to save money for a concert. He earns $15 per hour, that looks important, and needs at least $90 to go to the concert. And the question is, how many hours should he mow? So what we could say is that he has $15 per hour times some number of hours, and he needs at least, that means he needs greater than or equal to 90. From here, we're going to treat this just like we would have if it was an equation, where we're going to take and divide both sides by the 15 hours. These are going to divide out, becoming 1. 1 times h is h, which means he's going to need to mow greater than or equal to, that's going to be 6 hours in order to make all the money he needs to make. So it's an or equal to, we're going to have a solid circle. It's a greater than or equal to, the arrow is going to go to the right hand side. Let's take a look at the next one. Rachel can bake 8 cakes each day. That sounds important. So far, she has orders for more than 32 cakes, so we have greater than 32 cakes. How many days will it take her to complete the order? Now, this one's really similar to one we worked on the last page, but it's not quite the same. So we have more than 32, so she's going to has greater than 32 is what our goal, and we know that she can do 8 times some number of cakes a day. So once again, we're going to isolate our variable. We're going to divide both sides by the 8. These are going to divide out, becoming 1. 1 times c is c, and that's going to give me, not or equal to, that she's going to need greater than 4 days. So we're going to have an open circle because it's not an or equal to, and the arrow is going to go to the right for that problem. For number 8, Ranger saves $70 each week. So $70 times some number a week, I think, is what we're going to have. He needs to save at least, which means greater than or equal to, $2,800 to go on a trip to Europe. Not anymore. It's going to be more than that. How many weeks must he save? So we got $70 times some number of weeks. At least means greater than or equal to 2,800. So we're going to isolate our variable by dividing 70 on both sides. The 70 is going to divide out, and remember that trick I taught you where we can take and put a line through the zeros on the end? That makes our math a little bit easier. That's going to give me W is greater than or equal to, and we're going to take here, and 28 divided by 7 is going to be 4, so 270 divided by 7, that's going to equal to 40. So he's going to need to save money for 40 weeks. That's going to be most of a year or more. It's an or equal to, so we're going to have a solid circle, and the arrow is going to go to the right since it is a greater than. For our next problem, Clara has less than $75. So we know that C is going to be a value less than 75. She wants to buy 3 pairs of shoes. Okay, what price can Clara afford if all the shoes are the same price? So we know that 3 times, I'm going to change that C to be an S, 3 times the number of shoes that she buys has to end up being less than 75. So we're going to take and isolate our variable by dividing 3 on both sides. These 3's, of course, are going to divide out being 1 times S is S, and then 75 divided by 3 is 25, so it's going to be an not an or equal to, so it's a solid circle, and she has less than it for each shoe, so my arrow is going to go to the left-hand side. For our last practice problem together, the gym charges $25 per month. That tells me it's going to be 25 times something. Oh, wait a minute. Plus an extra $4 to swim in the pool for an hour. If a member only has $45 to spend each month, at most, how many hours can the member swim in the pool? Ooh, this one's hard. We haven't done this, all right? This is what we call a two-step equation, where we've got $25 he pays just to go to the gym, plus another $4 per hour to swim, and he has to keep it less than or equal to $45. When you're working these problems, the way we do it is we undo the addition and subtraction first. You've not been taught this, where you're going to subtract 25 on both sides. When we do that, these zero out, and they end up leaving me with 4 hours is going to be less than or equal to 20. From there, it's just like the other problems we use, where we're going to take and divide both sides by the 4. These 4s are going to divide each other out, and then from there we would take 20 divided by 4, making his hours have to be less than or equal to 5. So we're going to take and, yep, all that looks good there. It is going to be a solid circle because it's an or equal to, and the arrow is going to go to the left. So then actually that would be at most, which means we don't need an inequality. That one is actually, I did a little bit wrong. That is going to be an equal because it says that, and we'll leave it as an inequality. It's probably good that way. So we'll just leave it as an inequality, and boom, go like that. Now, what are you doing for homework today? You've got one page that's got 1 through 6 problems that you're going to be working on your own. Make sure you get it done well. Give me good quality supporting work for everything, just like the work I just gave you. And if you have any questions, I'll be happy to answer them tomorrow. I look forward to seeing you in class.